Okay, welcome to week 5 of Igm309. This week we're going to start talking a little bit about the way you apply transformations, how you use them in practice, what is a quaternion, and a bunch of other fun stuff that I'm excited to get into. And so the first subject we'll talk about this week is really simple, what's called Lerp. This is more of a coverage of what is a Lerp, because you're going to see this around your code and you'll be like, what does Lerp mean? What is that? That seems advanced, but it really isn't. Lerp is a very simple thing. It really just means a linear interpolation. And you can imagine, okay, we're talking about transformations, like say a translation, right? And I want to translate an object that's here and I want to move it here. And that's really easy to do with one frame, right? Like, okay, I'm going to move it. But say I want to move it and interpolate that movement across a number of frames or a period of time. And so you can imagine that a very simple equation can tell you, well, I'm starting from this point, I'm going to this point, and it's going to take me this long. And so at every time between the start and end time that I'm taking this object from one place to another place, like there needs to be a mathematical equation that describes where along that path that object should be. And that's what linear interpolation is for. So it's really useful for trajectories, it's really useful for routes, and going from one place to another. And really it's a pretty simple equation. You start off with your starting point, or y0, and then you subtract from it your y1 from your y0. That's the difference. And then you multiply your current your starting point, and you're trying to get to the end point. So that's the equation, right? Like you're basically taking the difference, you're just determining a vector, you're chopping it up into sort of the speed, dividing it by the time frame, and then you're applying just like x1, like 0.1 plus this vector times the delta time required to get there. You can create interpolation of, like kind of segments. You can kind of imagine for each segment you have the start point and the end point, and if you just sort of accumulate them, you can create a series where the start point when you're 0 and an end point, and the next one is the next start point is actually 0, and then the next end point. You can kind of accumulate them. So really all you need is a pair of 2 points. And in some cases you don't even need 2, you just need 1, because you're starting at 0 and then you're kind of resetting 0 each time you get to that. And we'll go through an example in the code as well to kind of talk about this subject. So yeah, it's pretty straightforward. It's pretty useful, but it doesn't really make sense for us to interpolate a matrix, right? Because it doesn't make geometric sense. The math doesn't really line up, and so we actually interpolate the components themselves. We interpolate the translation, the scale, or the rotations. And so you can imagine this idea isn't being applied to the matrix in particular. If you try to take a rotation matrix and a translation matrix, you kind of morph them, you're not going to get you're not going to really get that thing you're looking for, which is from one to the next, right? You're going to kind of create this weird morphing, and maybe there's non-linearities and scaling that you don't necessarily intend to have. And so what you can do is you can actually interpolate the value, like the x rotation, the y rotation. Later we'll see how to do this with quaternions and the interpolation of quaternions for this purpose, for specifically rotation. But in the meantime, what you can do is you can actually interpolate the specific components of the matrix related to the rotation, related to the translation. So there's a couple of interpolation methods that are already given to us by GLM called Lerp. It'll take a vector 2, 3, or 4, and it'll effectively represent the transition from a value of 0 to 1. So all now you have to do is, okay, 0 represents some time, 1 represents another time. So all you really have to do is give it a starting and an ending, and then sort of tell it where along the path, what percentage through. and that percentage can very easily then be converted into you can get that from the time, right? For like t1 minus t0 is the amount of time, and then your current time divided minus t0 divided by that, and you'll get the percentage. That's it. Lerping or linear interpolating is pretty simple, and so hopefully you kind of know what that means when you see it in the code, and we'll go through an example as well. Yeah, that's it for lerping.